Right. Thanks a lot, everyone. So I'm Hugo Cordeau, fourth year PhD candidate at the University of Toronto. So first, just thank you a lot. It's my first time in London. I'm really honored to be here today with a bunch of climate folks, and very fun to do that. So I'm going to talk to you about big push policy, network externality, and I'll talk about Quebec. So big picture, when there's network externality, mostly the type that chicken and the egg issue, what is the role of the government? And the thing I'm really interested about is, should they invest? And if so, how? I will look on one side, how does this affect consumer, but also how does it affect private investment as well? I will look at that in the case of electric vehicle. The reason why I do so, it's because it's a very interesting two-sided market. On one side, you have consumer that are keen to adopt electric vehicle. They consider certain characteristics, such as the range, acceleration of the car. But one thing that is very crucial for consumer is the charging ability of the network. So this is a very important factor to deciding to choose a car, electric vehicle or not. On the supply side, you have private firms that provide these charging stations. You can think about Flow, Electrify America. These firms are keen to provide this network if there's a lot of consumer. But if there's no consumer, it's doubtful that the private sector will offer it. The main issue is that there's network externality that they cannot capture. So they essentially provide a big network externality to the consumer on the EV adoption, but also to other network provider. So they don't benefit from the network externality they generate to the industry. The other thing is, if they do capture it, you will have a compatibility issue. And that led to over investment in redundant infrastructure that essentially don't really foster EV adoption. The thing that's very interesting is Quebec foresaw the need for this. So in the early 2010, Quebec, the province of Quebec went to the utility and they told them, you will build the charging network. You do not have to make money. You just have to ensure that the network is well connected. If you lose money, you can pass the cost of the electricity market. So for them, it's actually very simple to do it. So they try to utility to place location. The only condition is that it's a good coverage for the consumer. And just to be clear here, there's two types of charging stations. There's the slow charging station. This we can think about the on-street parking that has been issued in New York, London, Montreal, Toronto, for example. But there's other, and every day you come back to your home and you get 100% battery, okay? There's the other charging station, which is different. We talk about these few trips a year that you perform. For example, if you want to go from London to Oxford or Rochester, it's possible that you're worried that you not have enough battery in your car to do the trip. So our consumer responding to it, this is what we'll be working today. I contribute to literature in two ways. First, there's some paper that is doing some research on EV adoption. I mostly contribute there by showing how is the public provision of the charging network is affecting consumer adoption and how private sector respond. There's another growing research that is internal policy and coordination failure. When you have these different equilibrium path, you can have high adoption path, low adoption path, depending on the coordination. There's some job market paper candidate from this year. They essentially show theoretically some empirical evidence that with some nudging of the government, they can switch them to the high adoption path. I contribute here by demonstrating in the concrete case of the electric vehicle sector in Quebec. So I essentially show that this so-called big push policy can coordinate EV adoption dynamics. The paper in a nutshell is two questions. First, how is public provision EV adoption and private, how's the public provision impacted EV adoption and private sector deployment? And the second is, what's the kind of policy we want? What if we subsidize the private charging station? What if it's the state that provided? How is that different? I will use a structural model, which I'll justify in due time. Using two sets of data. The first will be charging station, charging data, transaction level. The second will be the EV adoption, registration data. So the one side, consumer will choose a vehicle based on the city they live in. So the city they live in impacted the quality of the network. And then they will look at the characteristics of the car. On the supply side, they will look at the EV adoption and the topography of the network. So if the network is very good, then you can make more money by your charging station, and they will build it when they make money. The supply side, the public here is taken as given. I'm not doing an optimal case. For the factual, I just draw the public sector. I want to know how is the public causing EV adoption. And the second, I want to compare these policies. So preliminary result, and again, I want to disclaim my model is preliminary. Currently, these results are better than it will be. I don't know by how much, but I believe this is the best they will be. Okay, so currently they're biased in my favor, if you will. So the correct big push policy, by that I mean this big deployment, doubled the adoption by 2022. So in 2022, the market share was twofold the one of the private sector for the factual case. And it was at $8 per ton of CO2. The one thing which is a flat subsidy on EV adoption is essentially very inefficient in the sense that it finances mostly infra-marginal charging station that would have been built otherwise. And this is mostly because these high social value charging station has low usage. So those that essentially connect cities are not built because they don't have that much usage, but they're very good for consumer adoption. And the third is an early push. It's just a thought experiment. What if we go and build just one charging station in each region? How will that impact the adoption? Do you see some crowding? Do you see some EV adoption? And here I found it's a very cost-effective way. It's less it reduces less greenhouse gases in the big push, but at a lower cost. In terms of data, as I told you, I have car registration. So I have the car registration from 2011 to 2022. 2023 is coming soon. For each city of Quebec. Here, what you can see is you have Montreal and you have Quebec City. Around 80% population lives here. Each dot is a city I have data. When it's a pale dot, there's a low EV adoption. When it's a redder dot, you have high EV adoption. So this have variation across space and time that allow me to identify how the consumer responding to the charging network. And charging usage, I have two sets of data. I have the public network, so I was able to have usage data. So I essentially have every single transaction performed in the network, and I can know their zip code, their consumer ID, so I can see pretty much everything they did. That's very handy to know people in the given city where do they charge, so that they them how much they value the other region where they charge. And also the private sector. So I web scrap charge up network using the first comment to know the entry decision of the private sector. I'm assuming that the first comment is the entry of the private sector. This will be used to know all the private sector is entering given some observable.
So can I ask if you observe prices per charging?
I do. So in the public network, I do observe it. The private, it's I could observe it. I currently do not.
I'm just curious how it varies between public and private sector, and if there's been changes in pricing policies, that could be another arm of this complementary.
They're very similar, just about maybe slightly more, but about the same. And also, it's very complex pricing system because you can price by quantity, and so I don't focus too much on pricing in this case, because I believe consumers don't respond that much price as this go around. They mostly impact on the ability of charging station is so much more important than the price you actually pay on it.
Yeah, but I guess it would matter for how much carbon you could offset with EV charging, depending on when you charge, if you charge in between hours or during your hours.
Yes, yes. A Quebec grid is 100% grid, 99.5. So essentially, it's not or it's very good point.
Okay.
Good. So that's a reduced form as well. So here I want you to look at this. As I told you, this is Montreal. This is Quebec. The main thing about that is the deployment of the public network. Each triangle is a new charging station from the public sector. And what I really want you to attract your attention in this area. So you clearly see a concentric expansion of the network. So each year there's new city being treated on the extensive margin of the network. So they were now able to use the network because they live too far to now I can access the network. Okay. So I will use this case, which is north of Quebec City. It's road 138. And the reason why I use this is because it's a very nice way, because essentially all the connected activity is south of there. So when they get connected, they essentially can access the network. So it's a north-south route, if you will. So I will perform a dynamic treatment effect. On the left-hand side, it's the market share, EV adoption. On the right-hand side, I will have some city fixed effect, year fixed effect, and then all the control will be relative to the year pre-treatment. I define a treatment as being a new charging station within 50 kilometers of your city. Most cities are relatively close to that way as well. Good. So the treatment effect here is around twofold increase. Here's a dynamic treatment effect graph. So you can see a monotonic increase through time, and the point estimate is statistically significant at twofold increase. Good. Now we talk about the model. And the reason why we really care about the model here is because now I just shown you that if you get connected on the extensive margin, you can twofold your adoption. This is interesting, but this is only true for the marginal city that already had an extensive network that get connected on the margin. What is the value of one charging station anywhere? It's very hard to understand. It is crucial to understand which policy we should put in place. This is why I have a two-stage demand. So the first stage of my demand is consumer. There's an exogenous number of people that want to buy a car that year. They look at the characteristics of the car and they choose if they buy an electric vehicle or not. Okay? You have some characteristics for the car, you have the price, and most importantly, you have the lambda O, which is the main contribution of this paper, which is essentially a sufficient statistics of the quality of the network in that city for that specific year. Yes.
That's a static object, right? So is it going to appear somewhere that people might be internalizing their project? What do you assume about people's expectations about how the charging network's going to expand over the lifespan of the car they're buying?
You're right. I'm assuming they look at 2 days here, this year, and based on 2 days network, do I take it? I'm assuming they're essentially myopic. That's all I model it so far.
Do they know the numbers?
They know that it will have more charging station. Do they know exactly where it will be? This not really. But the basis that we will build a lot of charging station. They don't exactly say where they will build it, but they say, as you can see, they essentially build it pretty much everywhere. So they don't specifically say that. There's 1,300 charging station.
Without specifying a fully dynamic model, you might be able to capture that by making different assumptions on that term, assuming they have different versions of dynamic projections. They're not randomly located. There's, as you said, there's some sort of radial projection. If they anticipate the next 3 years or 10 years, how different would your results be? Even without building the full dynamic expectation.
Yeah, I will consider that. My thoughts will stay the exact same thing, so it's pretty much that next step in the paper. I don't know exactly all will add up in the paper. I can just show, for example, the actual counterfactual case of what's happening, and that will help just make if they actually forecasted it with a different coefficient. That could be one way to do it. Which I think is very interesting. But this one is systematically asked every time. So as I was saying, a very important matrix is this lambda, which condenses the sufficient staticity of the charging network. Let me tell you how I built it. Essentially, you can think about someone that lives in the origin in the green and wants to go to a destination. So you obtain VOD utility of performing this trip. And the thing is very important is there's many destinations you would like to go. So I think the summation of all the places this person might want to go, there's around 90 regions they would like to go. So I think the summation of all the places they would like to go, but more importantly than that, is the quality of the network. So what's the network topography between the origin and the destination? Okay, so if where you want to go is a high value but a bad network, you don't get too much utility from it. It's a very good network with a high value, you get the point. Okay? And how do I build that? Each of these regions, so the pi is the product of each of these regions that are crossed. For a specific region R, like this one, we'll obtain an exponential decay. The purpose of exponential decay is the derivative is very handy for the counterfactual cases. And in addition to that, it's between 0 and 1. Okay. So it will have either 0 and 1, and then the product of something between 0 and 1. So you understand that this matrix will be condensed around that value. Good. So in the second stage, this is my V. This is how I estimated. You can think about this V as being the specific value you obtain from this origin destination trip. So you can think about population and distance jointly together will be a gravity equation. And then you have C, which is fixed effect of this destination that might just be very desirable. And now, how do I estimate that? And again, what I really want to show you is that I estimate them jointly. Okay, so you see that VOD is time consistent. So across time, it does not change. The only thing that will change across time will be the charging network. Okay, and what do I use to do that? So I'm assuming that each consumer in the city is performing 15 charges a year. And if I don't observe it in all of these cases, it will be in the outside option of that city. Okay? This should not be here, it's just OT. So essentially, if you have a very big left hand side, it means this region is very desirable given these two variables. If the left hand side is highly negative, then one of these two has to be very highly negative. Okay? And I use a multinomial logit to estimate the parameter here. Y'all following? Good. So the supply side, again, I want to precisely here talk about supply of the fast charging station, not EV. So these firms, they sell charges. Okay. So the high level is, and this is why I'm saying this is currently too good, is I'm assuming that the supply side is a set of single station owner. Okay, so normally the supply side will be owning multiple charging stations and they will have network externality of themselves. I will do that in a later stage of the project. Currently, they're single station owning. So in a specific region, the supply side firms will compete à la Corno. Okay, so way to understand that is if the number of charging stations in a region increase, that will reduce the price, thus the profitability you might get out of it. Good. However, this region could be like Corno, but the other region are actually complement. And there's two mechanisms upon which they're complement. The first is better network connectivity. For given number of EV, if we improve the connectivity of a specific region, you have spillover effect is positive of all the other regions that go through this region. The other point is if you have a better connectivity at that point, then all the cities that are going to that point at a certain point will have a better network. So that will lead to higher EV adoption. So these two things here are essentially causing a lot of complementarity to the state. And the way that the firms choose to build a charging network is they will take the best response knowing charging network, so all the competitors in the network, in the other region and your region, as well as EV adoption. So no one wants to change their strategy. This is what they invest. Good. On the supply estimation, what I use is, as I told you, I did some web scrapping to obtain the private sector entry. So I know there's a given number of EV adoptions. I know the flow that they can get, the revenue they can get at a specific point, and also know the number of competing charging stations that already exist. So now I know, for example, like given all these factors they enter. So it means they are revealing they're making profit. Okay, so as a rule of thumb, you can think as when profit is positive, then you enter. If profit is negative, you don't enter. That's how I estimate that. On the supply side, it's fairly stylized as of now. I'm saying they look at the current demand and they take the actual value future profit. So basic asset pricing. So there's three variable here, which is the discount rate. So this is something that will be estimated. So how much will be discount future revenue? The other is the inflation cost and also a region specific cost. Good. For the gain, just take a. For the gain, every period, so there's demand and supply. Every period start with the exogenous shock of innovation. So then there's this wave of new EV in that year, and then everyone knows that. And then there's government locking the charging station, and here I take them as given, not making the optimal case for the government. Third, private sector decide whether they enter or not at all of these points. Okay. And fourth, consumer choose the car, the vehicle, given the existing charging network. So here precise, again, existing, I can add some anticipation in the future as well. And repeat that T time. Essentially, I perform three counterfactual. I want you to look at the blue line and the red line for now. The blue line is what we actually observe. So this is on the x-axis is the year, the y is the market share. So what you can see is in 2022, the observed, what I call big push, reached a 12% market share. On the other hand, if it's the private sector, so I'm saying here the government did not build charging stations, but based on my estimation, the private sector will enter when they make money. So essentially chicken and the egg issue here. You will see a much lower penetration at around 6%. Again, once you include network externality and perhaps something fidelity with like Tesla, for example, you shall see this be much better. Okay, so this is like underestimation. So you can see a twofold increase in 2022. The other thing I want you to look is the station subsidy. So here I'm saying, if I get a 50% subsidy to the charging station, what will be the impact on the adoption? And surprisingly, I was very surprised to see it's that little. Even if you 50% increase if you reduce by half the cost of the charging station, you barely see an increase in the adoption. And it's because most of these charging stations that are built are those that were already profitable, and they will only add slightly whatsoever in a very high usage area, instead of building on these places that actually have a lot of social value when they are built. So there's this business alignment between the private and the public value. So flat subsidy is not optimal. There's many ways to do policy that makes this more desirable. So let's say policy is bad. I'm saying flat subsidy is bad. Yes.
So in the counterfactual here, you're taking the spatial distribution of public charging stations this year.
Yes.
Does that say the government did a very good job in finding places to put the charging stations in? Back out.
So this is something I want to do, is to go. One way is to have some model that say the government maximize. So you understand. So I do have a model of what's the policy function of the government. Assuming the government maximize the accessibility. You remember the lambda I showed you? Imagine if the government every period was to maximize this lambda. So I would like to do some like pulse tests, for example, like if I were to build the one that has the highest value in every year, how will that change versus what they actually build? To answer your question.
Yeah.
So as of now, I do not think this is the optimal network. I think it was fairly good policy. I'm not saying this is, they did a good job. Cool, they did better. I think so.
What is the percentage this of all vehicles?
This is 12%.
Is it all vehicles on the road?
On the roads around 3% in 2022.
Sorry. The measure here is all vehicles. This is the percent that are EVs.
Yes.
Okay, so
Sorry, yeah.
what if you
Of all the sell in 2022,
almost to the new vehicles?
yeah, the sell for the people that are registered in 2022, 12% were EV.
Okay, so the max then would be 100% if they're all EVs.
Yes. So it's very far from the max. Yeah, I do believe the network might, even if you have a much better network,
But in terms of vehicles on the road, the percentage would be even lower.
yes,
Many
yeah.
older cars would do.
Of the fleet, it's around 3%. In the highest adoption city, you see 8%.
Okay.
2022, it's increased exponentially. Yeah. The other thing that is, I think, very interesting is the small early push. So here I'm trying to find some qualitative insight for the policymaker. So here I'm saying, hey, the flat subsidy is maybe not optimal because they will just go where they make money and they will not build what you want them to do. And this is actually an issue in BC, by the way. They really face this issue. Here I'm saying, how about we just do this counterfactual, which we build one charging station in every city in 2017 and see how is the private sector and EV adoption responding. The perks of that, it's kind of embedded in the model, it's a disclaimer here, is that once you build one charging station in every city, now the network is accessible, okay? And this, you do see substantial increase in adoption relative to the private. It's still much lower than the observed one, but this is much cheaper to build. Let me show you how much cheaper. So here we have, each column is a policy, each row is a different element. So the first row, you can see the number of new EV fleet as of 2022. So the sum of all the new EV. So the big push essentially caused 140K new EV. The flat subsidy of 15, and the early push 15K. And social benefit, you can see, depending on the social cost of carbon that you take, it's fairly high. We talk about a few hundred million to even $1 billion for fairly high social cost of carbon. And the policy cost was fairly cheap. Talk about the 50 million to generate such a high adoption. So it's fairly affordable here. As a disclaimer, they also have a subsidy here, which I don't think I fully capture well in this red network. And the thing is very important is the cost of abatement per ton. So we do find $8 per ton for the big push. The flat subsidy is at 22, so it's relatively cheap still. And the early push is very cheap. We talk about $1. Again, I want to underline, say it 3 times. My supply is not optimal. My demand will be improved too. So let me conclude. This paper found two things: deploying the charging network foster EV adoption. Most importantly, big push and early push are a highly effective policy to foster EV adoption. And on the other hand, fat EV subsidy is perhaps ill-informed because of this misalignment between the private and social value of the charging station. And it contributes to two strands of literature: one, a non-financial incentive for EV adoption, as well as the one for coercing private firms to install policy. So thanks a lot for your